So, hello everyone. So a new day, a new task. Yeah. Let's check the new exercise, which I want to show you today. So it's called longest repeating character replacement, which is of medium type. And let's check the condition. So you are given a string s and a number k, and you can replace any k characters in the string. So we need to find the length of the longest substring where all characters are the same after at most k replacements. And below we have an example where we have a string a, b, a, and so on. K is equal to 1. Again, k is how much elements in this string we can replace. And the result will be 4. Why so? Because let's imagine that we iterate through our array. We see the first character A, second character A. We point now to the B character. We select the most frequent character, which is A, and we replace B with A. Now we move forward A, and at this point our max length, which we already found, is 4. So when we go to the next element B, we cannot replace it anymore because we already have done this for the first B. So the length, the maximum length in this string will be 4. Okay, I think we can move forward. So let's answer to some questions. I think it's a good approach to better understand the task and in general what we need to do. So let's check what kind of questions. So when is a window valid? What is maximum frequency? And what pattern fits here? So let me answer to these questions. So when is a window valid? A window is considered valid when window size minus maximum frequency is less or equal to k, and the most frequent character stays, everything else gets replaced. So what does it mean? So let's imagine the situation when we have a string with characters a, b, a. So in order to know how much elements we need to replace, we need to take all elements, so a, b, a, length of these elements, which is equal to 4, and to find out which character is most frequent in this string, which is a, and the length is equal to 3. And we subtract from 4 this 3, and we get 1. And this one will be the count of elements which we need to replace in order to make this string to be formed from the same elements. So I hope this is clear. Actually, in the description, I think I will leave URL to some short video which visualize how you can use a sliding window pattern in order to better understand this task. So what is maximum frequency? The count of the most frequent characters in the current window. We want to maximize it. And what pattern fits here? So I already mentioned about it. So I think that a good approach to use here is sliding window, because we can expand the right pointer, shrink left when the window becomes invalid. So that's it. Now let's go and try to see the potential solution. So let's create our method. So let's write public static, and now we've already identified from the condition that we want to return the maximum length. Yeah, so we need to return int, and let's call our method find longest repeating character replacement. Okay, cool. And now let's add some arguments here, so we will need an array of characters, char array, and also we will need a number which will indicate how much elements we can replace. Yeah. Okay, and now usually when we use sliding window technique, we need to have two pointers, left and right. So let's create them, left and right. This we will use in order to iterate through our array. Also, I think that we will need to have maximum length found. Here we will store maximum length found. Here we will store the maximum length which we will find in our array, so it will be our solution. And let's also define a variable maximum frequency, which will store the current frequency, current maximum frequency in our window. And also let's define the map where we will store the characters from our window and also their frequency. So the key, let's be character and integer frequency, and let's call it character frequency. Character frequency. Okay, cool. Nice. Okay, so we have defined all necessary variables, and now let's create a loop because we want to iterate through our array. So let's create while, and we will iterate while right is less than array length. Here actually you also can use simple for when you defined int e is equal to 0 and so on, but I like to use this style. Okay, now let's understand what is our next step. So what do we need to know and to find? So the first thing, we need to know how much elements do we have in our window. So because this number will we will use in order to subtract the maximum frequency and to understand how much elements we need to replace and to compare with our k value. So let's define a variable int element in window, which is equal to right minus left plus 1, and this will be the length of all elements in our current window. And now let's take our first, actually let's take the element for current iteration and let's increase frequency for that. So we will need our map character frequency, and we will need to put here our current element, right? Okay, and character frequency get our default if it's first unique element in our map. Here we will need array right. Okay, default value will be 0 plus 1. Okay, cool. And now let's find out what is the maximum frequency. So which element in our window actually not it's not very correct formulated. So the maximum frequency in our window, yeah, what it is. So if we have again in our window elements a, b, so the max frequency will be 2, yeah, because we have 2a, 1b, so the max frequency is 2. So let's calculate maximum frequency, which is equal to so we need to compare the maximum value between previous maximum frequency which we have and the current frequency and the current element frequency. With that frequency get array right. Cool. So if the current frequency of the current element in this iteration is better, then we will change the value for maximum frequency. And now, having all these values, we can calculate how much elements we need to replace. So let's call element to remove or replace element to replace, which is equal to element in window, elements in window minus maximum frequency, and that's it. Okay, and now let's check, let's find maximum length found. Yeah, so we need to compare again the maximum value between maximum frequency and the current length of the window. Right minus left plus 1. Okay, and let's move the right pointer to the right. Cool. But also here we need to cover the case when element to replace is higher than allowed. Yeah, so when it's higher than k. So let's create a while loop. I will make a small spoiler. Actually, this approach which I will use here, I will recalculate a maximum frequency on this while loop, and I will explain why. But this approach is not the best one, and we will see the best one in the next video. But yeah, it's like a small spoiler. So let's continue, and let's verify if elements to replace are, this number is higher than k, and also we will need here a condition that left so is less than right. Why we need this? Because inside this loop we will change the value for the left pointer, and it should not be greater than right. Yeah, so left should be less or equal to this value. So maximum they should point to the same element. And now if we will move left pointer to the right, we will need to take the element from the left, yeah, and to decrease the frequency, yeah, because we remove this element from our window, so we need to decrease the frequency. So we take our map character frequency, we like a key will use the current element, so array, not the current but the left actually, because we move the left element, how I already mentioned, and we will need to decrease the frequency. So we take character frequency, get array left -1. Okay, and now let's move the left pointer to the next element. So why do we need to do this? Yeah, so let me show you. So let's imagine that initially I started to A element, then to A element, then we are on B element. We replace this element with A because we have this replacement here, 1. Then we go to the next element, and now our maximum length, which we have already found, is 4. And we go to the next element, B. And in this point, we already cannot replace this B because we already use our replacement for the first B. And now we need to move our pointer, which is still left pointer, which is still on the first element, till the condition will become valid again. So we will move it to the next element, to the next element, to the next element, while we will not reach this B, and from this point, when a right pointer and left pointer will be at the same, will point to the same element, we will start to find a new possible better length if it exists, and by doing so we will find the best solution. So let's move back. Okay, so now let's recalculate. So yeah, here we removed. Okay, we moved the left pointer. Now, because on our while loop we use element to replace, we need to recalculate this value. Yeah, because it should be different in every iteration. And what do we have? How we calculate the value for element to replace? Yeah, we take all elements in window and subtract maximum frequency. And now, because we move the left to the right, our window is shrink, so it becomes smaller, and the element in the window should change. Yeah, and maximum frequency also, because we remove one element from this window. And actually, it can change, it cannot, it depends. But if, for example, we had A, B, A, so the first element to which initially left pointed is A, we move left pointer to the right, so now 1A is not in our window, so maximum frequency potentially can change. But if, for example, it was B, but our element with the most frequency is A, then maximum frequency will not change. So it depends. But element in the window will be changed 100%. And now, so because we need to recalculate element to replace, because it's used in our while condition, what do we need? So we need element in the window. Yeah, so let's recalculate it. Element in the window, which is equal to right minus left plus 1. And also we will need to recalculate maximum frequency, and how I already mentioned, what I will do now is not the best option, and the better approach I will show you in the next video, but it works and it's possible solution. So what I will do, I will create a new while here. Why so? Because I need again to iterate through my maximum frequency, actually through my map character frequency, and to check if maximum frequency haven't changed. And so for that I will need to iterate and to check all frequencies in that map and to take the better one, yeah, the highest one. Why I need to recalculate? Because again I change the left pointer, so potentially our maximum frequency can change because we remove an element from our window. So let's do this. Let's create this. Actually, I think I will use here for loop. Let's reinitialize maximum frequency variable. Should be again 0, and I will use for each integer. Why integer? Because I need to know frequencies, and in our map frequencies are integers. Frequencies. Frequency. And I will take values from our map frequency, frequency values. And now let's compare each frequency and select the highest one. So max frequency is equal to max maximum frequency and current frequency. Okay. And now, having element window, new element in window, and new maximum frequency, we can recalculate element to element to remove, to replace. Element to replace is equal to, so we take element in window minus max frequency, and that's it. So now I also forgot to change max length found, yeah, the most important thing which we need to do. So let's here actually max frequency. Okay. Let me think. Actually, this is not correct. So here should be maximum length found. Maximum length found. Yeah, because the maximum frequency is the variable which stores the maximum frequency from the current iteration, but not the overall one. Yeah, so we update this, and now let's return maximum length found. Here also again maximum length found. Okay, so I think solution looks good. Okay, and now let's call method public static void main, and let's call this method find. Let's define an char array. A, B, A. Okay. And like this. Okay. Where's the mistake? So here. Print the len. Let's close there. Okay. Oh yes, I forgot this thing. Okay. Now let's check how does it work. Okay, so yeah, you can see that the maximum length is 5. Why so? Because we have A. Now we replace B with A and A, so the maximum length will be 5. If, for example, here we will change, let's say 0, then maximum length should be 3, because we have A, B we cannot replace because we have 0 replacement. And let's check if it's really 3. Yes, it's 3. So that's the solution. Okay, let's go and analyze the complexity. So the time complexity is O(n) kappa, because the right pointer scan the array once, and in that case the complexity is O(n). Using sliding window technique, again I will attach a link on the description. You can see visualization how does this algorithm works, technique better say. When the window become invalid, the while loop moves the left pointer and recomputes maximum current length by iterating through all values in the hash map, which costs OK, where K is the number of unique characters. Because this recomputing can happen many times, the total complexity become O(n) kappa. Now let's check the space complexity. So space complexity is O kappa. The algorithm stores characters frequencies in a hash map where k is the number of unique characters in the window. So that's the solution. I hope it was helpful for you. In the next video, I will show how we can optimize the solution. So if you are interested, you can watch. Thanks.